Okay, good evening. So today is the last day of modulus functions and modulus graph. Okay, now silence. So up to now we have done in silence. We have done how to draw the modulus functions, and based on that we have solved modulus inequalities. And I told you there are two main ways to solve a modulus inequality. And so far we have discussed the graphical method. So far, what we have discussed is the graphical method because I was focusing on this method. The reason in A levels, what you are supposed to do first, you need to sketch the modulus graph, the given modulus graph. First, you need to sketch the given modulus graph, and then only you have to solve the inequality, which means they are expecting you to do this in the graphical method. So today there are two main parts that we need to cover. One thing is using a substitute in when solving modulus inequalities, and the other one is we need to sketch some special kind of modulus functions, the modulus graph. So this part we have to done today. We have to do today. We have to complete this by today. And after that, at the later part, I'll be giving a brief idea about the algebraic method to solve modulus inequalities. I told you there are two methods, and one method is the method that we have been doing so far, the graphical method. So at the later part of the class today, I'll be discussing about the algebraic method, how to solve a modulus inequality using the algebraic method. Okay, so write the topic using a substitute, using a substitute using a substitute in modulus inequalities. Using a substitute in modulus inequalities. Using a substitute in modulus inequalities. Okay, now this is the thing. Let's say when you solve a modulus inequality, so I'll take a example. I'll do this. Okay, I'll take this 2016 question. So I'm taking an example, the 2016 question. They were expecting us to solve the modulus inequality. A modulus x plus 1 is greater than 2 times x minus 1 modulus. So this was the question that we got from 2016. So I'm taking this one because I need an exact answer. So this was the 2016 A-level question. So what did we get as the answer here in 2016? What was the answer? Okay, so here we have got the answer. When you solve this inequality, this is greater than this when x is greater than 1 over 3 and less than 3. So this is a solved answer. So I told you this modulus function question or the modulus inequality question comes as the second question in the PU Maths paper. So the PU Maths paper, by now, there are 10 first part questions, short questions, compulsory questions. And in the second part, there are 7 questions. Out of the 7 questions, you are supposed to do 5 questions. So that is basically the structure of the PU Maths paper, and it is repeated in the applied maths paper. 10 short questions, compulsory questions, and we have 7 essay questions. Out of 7, you need to do 5 questions. So this question, let's say from 2000, you can see the question has been repeated since 1990s or 1980s even. So since 2000, from 2000 up to 2015, 16, it was the same thing. It was the same thing that you have been given to sketch the modulus graph, and then you need to solve the inequality. So one thing that normally the professors or the let's say the paper panel who is compiling the papers, one thing that they do, like in every subject, even in the O levels, they might do that. Let's say that they are given a question in the repeated way. එකම දේ දිගටම දෙනවා. So you have been given to solve the modulus inequality after sketching the modulus graph, and this will be given repeatedly. Again and again, you are getting the same type of question, same structure. So then they suddenly get this idea that we need to change the question. We need to do a small change. Not that they are going to give something that is out of the syllabus, that they tend to change the structure of the question. So this happened in 2019. In 2000 up to 2018 question, like if you, I think we have even done the questions up to 2018, except these quadratic functions, remaining stuff we have done. So in 2019, there was a small change in the question. So that happens in every unit. For example, the most common question in the POMETS paper, what do I mean by most common? The highest possibility of selecting that question by a student is the differentiation graph question. So the differential graph question is the question that is being selected with the highest probability. So even in that question, it was being repeated in the same structure since 2011, but then they changed the structure in 2013. අර එහෙම පොඩි පොඩි ආතල් ගන්නවා. They change the structure. Even though it's a small thing, when you go to the exam, let's say you practice doing like, for example, in the classroom, you are doing 30 modulus inequalities. And in papers, you do more than 60 modulus inequalities. So before going to the A-level exam, you have done around 100 modulus inequalities, and you go to the exam and you see a different structure of the question. So even though it's a small change, that is a huge impact in that student's paper because you are practiced. You have been practiced to do this question. So that's why you need experience. So this change happened in 2019. So this question, I'm taking only an example. So this change happened in 2019. So let's say when you solve this, so this is the answer that we have got. But in the question, they are not expecting us to get this inequality. Let's say after sketching, initially you have been given to sketch these two graphs. Y equals modulus x plus 1 and y equals 2 times x minus 1. So you have been given to sketch these two graphs. So if we are supposed to sketch these two graphs and we have to solve this inequality, it's clear that you got one graph in one side and the other graph in the other side. So you can solve it. But the question is quite different. They're asking a question like this. Solve the inequality 2 times modulus x plus 1 is greater than 2 times 2x minus 1. 2x minus 1. So this is the inequality that they have been given. Initially, they have asked you to solve this, to draw this 2 modulus graph. So after drawing this, if they gave the question to solve this inequality, that you can do. But they are not giving that one. Rather than giving this inequality, they have given a different inequality. So now it's a problem because we have drawn or we have sketched these two graphs. And I told you when we are using the graphical method to solve the inequality, the two functions that you have sketched should be in the both sides of the inequality. Should be on either sides of the inequality. Here we should have one function and here we should have the other function. But the thing is, it's a bit different. It's clear it's a bit different from the modulus functions that you have sketched. So for this purpose, we need a substitute. So what we do here, let's say that you are after drawing these two graphs, after sketching these two graphs, you are supposed to solve this inequality. So what do? I forget about this inequality. I just write it somewhere. And I'm going to solve this inequality. So what is this inequality? We don't know what is modulus 2x plus 1, but I know what is modulus x plus 1. We don't know the graph of 2 times modulus 2x minus 1, but I know the graph of 2 times modulus x minus 1. So what do I do here? Rather than this one, I'll be keeping this away and I'll be solving the inequality consisting of the functions that we have sketched. So now forget about this one. So you know the answer. So you have been given to solve this one. So first thing is you need to write the inequality which is equivalent to the graph that we have drawn. So instead of 2x modulus 2x plus 1, I'm writing, okay, modulus x plus 1 is greater than. Instead of this one, I'm writing this because this is the graph that I know. So instead of this one, I'm writing this 2 times modulus x minus 1. Since I have drawn these two graphs using the Cartesian plane, I'm going to solve it and I get this answer. And then you need to think about a substitute. You need to think about a substitute that makes this inequality. You need to think about a substitute that will convert this inequality up to this inequality, because you are supposed to solve this inequality. You are not supposed to solve this inequality. You are supposed to solve this inequality. Okay, so here you need to think about a substitute that will convert this inequality up to here. So it's clear x has become 2x, x has become 2x. So what is the substitute that I'm using here? The substitute will be, I'm going to replace x by 2x. I'm going to replace x by 2x, and this is the substitute that I'm going to use. I'm going to replace x by 2x. And now it's clear, when you replace x by 2x, you get 2x modulus 2x plus 1 is greater than 2 times modulus 2x minus 1. But when you replace this x by 2x, make sure you even need to replace this x by 2x. Even this x should be replaced. So then you have 1 over 3 is greater than not x, it's greater than 2x less than 3. But always, even though you replace x by 2x, the final answer should be in terms of x. The final answer should be in terms of x. So how you can get x here easily? When you divide it by 2, you get that x is greater than 1 over 6, but it's less than 3 over 2. X is greater than 1 over 6, but it's less than 3 over 2, because even though you replace, make sure that your final answer should be in terms of x. Okay, so what we do here, when you have been given to sketch these two graphs, and you are supposed to solve this inequality, a different inequality. First thing that you need to do, you need to write the inequality, or you need to change this inequality using the functions that we have drawn. So this one you don't know. Modulus 2x plus 1, that you don't know. So instead of that, I'm writing modulus x plus 1. And even this one you don't know, we haven't sketched it. So instead of 2 times this, I'm going to write 2 times this. So then, using the modulus graph, you can solve it. When you solve it, you get this answer. So this is the answer that we got in 2016 question. So I'm going to solve this. Okay, now when you solve this, then look at these two inequalities and think of a substitute that will convert this inequality to this one. That will convert this inequality to this one. So here it's clear that x has become 2x. So my substitute should be x becomes 2x. But when you replace x by 2x, make sure that even in the answer, x should be replaced by 2x. So after that replacement, again, here the final answer should be in terms of x. So I divide it by 2, and then I get that x is greater than 1 over 6 and less than 3 over 2. Got it. I'll tell this in Sinhala for the better understanding. එතකොට මේකේ මොකද්ද කරන්න ඕනේ? ඔයාට දෙන්න මේ inequality එක solve කරන්න. එතන මේ inequality එක දුන්නාම ඒක වෙනුවට මම කරන්නේ මම ඇඳලා තියෙන functions දෙක use කරලා මම එක inequality එකක් ලියනවා. දැන් මේක තමයි දීලා තියෙන්නේ. ඒක හිතන්නේ නැහැ. ඒක වෙනුවට මම කරන්නේ මම ඇඳපු functions දෙක දාලා අලුත් inequality එකක් ලියනවා. ලියලා මම ඇඳ graph එක පාවිච්චි කරලා මම මේ inequality එක solve කරනවා. මේ inequality එක මම හොයනවා. හැබැයි මම දන්නවා ඒගොල්ලෝ අහන්නේ මේ inequality එක නෙමෙයි. ඊට පස්සේ බලන්න මේ inequality එක කොහොමද මෙතනට convert කරන්න කියලා. ඊට පස්සේ බලන්න මේ inequality එක කොහොමද මෙන්න මෙතනට convert කරන්න කියලා. එතකොට ඒකට දාන එක තමයි මේක තමයි අපි substitute එක කියලා කියන්නේ. එහෙනම් x කියන එක කෙනා 2x වුණා නම් හරි you get this inequality. ඊට පස්සේ ඒක කරාට පස්සේ answer එකෙත් ඒක replace වෙන්න ඕනේ. හැබැයි answer එකේ 2x replace වුණාට මතක තියාගන්න අන්තිම උත්තරේ හැමතිස්සෙම එන්න ඕනේ x වලින්. Your final answer should be an inequality in terms of x, not 2x or anyone else. Okay, so this is how we use a substitute. Okay, okay, write in this way. Write in this way. After sketching the graphs, after sketching the graphs plural of the given functions, comma, if the given inequality is slightly different from the functions that we have sketched, comma, we can use a substitute to solve the given inequality. Okay, so then write in this way, look at the board from the 2016 A-level question. Okay, you got this one. So you got this one. And then put this substitute. It's clear when you put the substitute, x should be replaced in the inequality and even in the answer. X should be replaced. So first write from the 2016 A-level question. This. Then write this one. When, and you got the answer. And then use the substitute. Okay, so after getting this one, then write in this way. So after getting the final answer, write in this way. When replacing x by 2x, after this one, when replacing x by 2x, x by 2x, comma, x in the answer should be even replaced, or even should be replaced. X in the answer even should be replaced. And write this in a black pen. The final answer should be always kept in terms of x. Should be always kept in terms of x. Okay, let's start the 2020 A-level question. Start the 2020 A-level question. First, sketch the graph. Then I'll explain how to do this. 2020. Silence. Do the 2020 A-level question. Silence. Draw the two modulus graph first, 2020. So when you consider these two modulus graph, so now you know how to sketch them directly. You get 3x minus 3 and minus 3x plus 3. So this is when x is greater or equal to 1. This is when x is less than 1. And here you get x plus 3 and minus x plus 3. When x is greater or equal to 0, here when x is less than 0. So first what I want you to do is sketch the two graph, the same diagram. So here if you consider first one is modulus, this one, let's go with this. The turning point is x equals 1 and always consider the turning point. So when you put x equals 1, it's 0. So it goes through this point and 3x minus 3 goes in this way and minus 3x plus 3 goes in this way with a intercept of 3. So I told you use the small details that the intercept is 3. So then it will be important in the next one for the next graph. So here you got y equals 3x minus 3. When you consider x plus 3 and x minus x plus 3, the intercept is 3, but the gradient is less. The gradient is 1. So it goes in this way. There is interception here. And the other one, minus 1, the gradient is in here. Because this is minus 1 and this gradient is minus 3. So y equals minus x plus 3. And this one, it's y equals x plus 3. Clear. Okay, then after sketching these two graphs, look at the inequality that they're asking. So what is the inequality that you're supposed to solve? It's 2020. It's 3 times modulus. So this is the inequality that you're supposed to solve. This is greater than 2 times modulus x plus 3. Okay, now this is the inequality you are supposed to solve. Okay, okay. So now this is what you have to do. Okay, listen. So forget about this one. Because we haven't sketched the graph of this, or even we haven't sketched the graph of this. So forget about this. Looking at this inequality, write the inequality in terms of the function that you know. So you don't know this one, but you know 3 times x minus 1. That you know. So just looking at this, write the function that you have sketched. Write the function that you have sketched. This is greater than, I don't know this 2 times this one, that I don't know, but I know x modulus x plus 3. So that's why I told you, after sketching this graph, so this is the inequality that you have been given to solve. Forget about this one, but looking at this, write the inequality using the functions that you have drawn. Is it clear? So now it's clear. So what we got in the left hand side, yeah, what we got in the left hand side, it is the first function that I have drawn. This is the first one. And in the right hand side, that is the second function that I have drawn. So this is the first one. So that is in the left hand side, and this is the second one that is in the right hand side. So I told you, forget about the inequality that they have been given. Write it in terms of the functions that you know. And now solve it. Okay, now solve this. It's clear. So when you solve this, you have to solve where this one is great. You know, the black colored one is great. So it's clear the black colored one is greater. In this region, it's greater. The black colored one is great in this region. And after this point of intersection, again the black colored one is greater. After this point of intersection, the black colored one is greater. So you need to find this one. Okay, let's find it. What is that intersection point? Who have been intersected? Y equals 3x minus 3 and y equals x plus 3. So when you solve this, x, yeah, it's x plus 3. You get 2x is equal to 6, so x is equal to 3. So you get this point of intersection, it's 3. Clear. Okay, so first solve that. Forget about that one. In the end. Just look at that, write this, and then write the answer. Okay, this is when x is less than 0 or x is greater than 3. So you get this answer when x is less than 0 or x is less than 3. Got it. Okay, hands up if this is clear up to this part. Hands up if this is okay. Now what we have to do, look at these two inequalities. Make amata karane kya nahi ke, hima amata karane ba. Just keep it. Look at these two inequalities and now tell me, how can you convert this inequality up to here? How can you convert this inequality into this inequality? What is the substitute that you need to use? Just look at one point. X has become x has become 2x. X has become, so we can take the 2 out of the modulus. So that is okay. So even here, x has become 2x. So what is the substitute that you're supposed to use? You need to use x should be replaced by 2x. Is it clear? So here, I'm using I'm replacing x by 2x. So when x has been replaced by 2x, you get 3 times 2x minus 1 is greater than modulus 2x plus 3. So here we can take a 2 easily out of the modulus. 2 times modulus x plus 3. Okay, when make sure you even replace x in the final answer. So x should be replaced by 3x, sorry, 2x less than 0 or 2x is greater than 3. But can you keep this as the final answer? No, your final answer should be in terms of x. Should be, hey, wake up, wake up, wake up. So many sleepy faces. Okay. So your final answer should be in terms of x. So I divide by 2 to get x is less than 0. It's one answer. Or here it's x is greater than 3 over 2. So here x is greater than 3 over 2. Okay. Is it clear? Then you have drawn this one. Solve this inequality. We need to write the inequality based on this. Looking at this, write the inequality in terms of the modulus functions that you have sketched. Make a mama 3 times modulus x minus 1. This one I don't know. What I know is modulus x plus 3. Okay, then do this. After completing this, do the 2019 question. First complete the work here. After completing it, then do the 2019 question. Silence, silence, silence. You don't copy paste the board, just get idea and with the understanding, write it. Just don't blindly copy paste it because we are doing maths. After this, do the 2019 question. You start the 2019 question. Same thing. First row the given two modulus functions and then instead of the given inequality, solve the inequality in terms of the functions that we know. Silence, silence, do the work that I have given a question. 2019. Okay, so 2019, first we have to sketch y equals a 4x modulus 4x minus 3 and then y equals to 3 minus 2 times modulus x. So here it's 4x minus 3 and minus 4x plus 3. The turning point is 3 over 4. And here you get 3 minus 2x and 3 plus 2x. The turning point is x equals 0. So I told you now we know that last day when we discussed about the shapes that we get in a modulus function. So here when it is a minus in front of the modulus, you get this opposite of the v. So we need to make sure that you consider that when you are drawing the graph. So here, let's go. Here we have the Cartesian plane and then first sketch this one 3 over 4. So at 3 over 4, it's clear. it's 0 and the gradient is 4, no? So gradient is 4 means it's a create a gradient and the next one will be 2. So if you consider that the gradient, okay, 3 over 4, consider the gradient 3 over, sorry, the gradient is not 3 over 4, the turning point is 3 over 4, it goes in this way. And the intercept here is 3. So what are the two graphs? This one is y equals 4x minus 3 and this one is y equals minus 4x plus 3. And then the next one is the intercept is 2, sorry, 3 and the turning point is 0. So you can sketch 3 minus 2x in this way when x is greater than 0. So minus 2x means the gradient is less than this one. And here it's 3 plus 2x. This is y equals 3 minus 2x. And this one is y equals 3 plus 2x. Okay. Then find the intersection points because we know we are going to solve this inequality. This is 0. Find this one. So when you get this, you get. So what are the two graphs that have been intersected? It's a 4x minus 3 and 3 minus 2x. So 4x minus 3 is equal to 3 minus 2x. You get 6x is equal to 6. So the turning point here is 1. Sorry, the intersection point is 1. Now look at the inequality that they have given. So after sketching this, so this is a normal thing that we have been doing for the past 3 weeks. And then look at the inequality that they have given. So what is the inequality? We are supposed to solve this. 2x plus 2x minus 3. 2x minus 3 plus modulus x is less than 3. So anyways, it's clear that this is not the graph that we know. So they are expecting us to solve this inequality 3 minus modulus x. And what we have to do, looking at this, make it a main. Looking at this, write the inequality in terms of the functions that you have sketched. Okay, so tell me, do we know 2x minus 3 modulus? Do we know this? No. What is the modulus function that we have sketched? Tell me, what is the modulus function that we have sketched? 4x minus 3. So, okay, instead of this, write 4x minus 3. It's less than. Do we know the graph of 3 minus modulus x? No. What do we know? 3 minus 2 modulus x. So, looking at this, right, 3 minus 2 modulus x. And then write the answer. Okay, this is this. So they are asking that the black colored one, no, the blue colored one should be greater. Okay, the blue colored one is greater in this region. The blue colored one is greater in this region. Okay, then what is the inequality when x is greater than 0 but less than 1? And now what you have to do, looking at this one, think of the substitute that gives you this inequality. I told you, look at one point. 4x has become 2x. Half of that, no? 4x has become 2x. Meanwhile, 2x has become x. 2x has become x. So it's clear that it's half of this. Half of 4x is 2x. Half of 2x is x. Okay, then you tell me, what is the substitute that you need to use if you want to convert 4x up to 2x? It should be, x should be replaced by half of x, so x over 2. Clear? Because it's clear. Look at one point. 4x has become 2x. So what is the substitute? X should be replaced by x over 2. So now when you replace x by x over 2, 4 times x is replaced by x over 2 minus 3. Minus 2 times x has been replaced by x over 2. Then it is clear this gives you 2x minus 3 modulus is less than 3. and these two cancel off minus x. So this is the inequality that they are expecting you to get. So what is the substitute? X should be replaced by x by 2. So when, make sure you even replace x in the final answer. So x, not x, x by 2 is greater than 0 but less than 1. Even this x should be replaced. But your final answer should be in terms of x. So multiply either side by 2. 2 into 0 is 0. X is less than. To get the final answer, multiply each side by 2. So your final answer should be x is greater than 0, less than 2. Okay, hands up who got this, sons? Got this. Okay, good. Complete the work. I'll give like 1 minute to complete this. Okay, write a subtopic. A subtopic. So don't write it in a black or red pen. Just write it in the blue pen and underline in the blue pen because that is a small one. Not a topic. Silence, silence. Not a topic inside the modulus graph lesson, but we need to have the knowledge of this in order to move on to the next step. Write a small topic for graphs of quadratic functions. Graphs of quadratic functions. Graphs of quadratic functions. Okay. So when you have been given a quadratic function, how can we sketch the graph? So if we start with the simplest thing that y is equal to x squared, okay, y is equal to x squared. Hope you can remember it. It goes in this way. It touches the origin and goes in this way. So this is the basic, the first quadratic function that you get, y equals x squared. Can you remember what is the name of the shape? The name of the shape? We call it as a parabolic shape. So the shape is a parabola. So this shape, it's not a circular one or another one. It's a parabolic shape. And this one, we call this as a minimum. So this is a minimum. Anyone can remember what decides whether the quadratic function has a minimum or a maximum? What is the factor that it is dependent on? Can you remember? Saapela ganite. The sign of the not x, sign of the coefficient of x squared. So what depends? So what is the factor that decides whether this is a minimum or maximum? It's the sign of the coefficient of x squared. If it is positive, then it is a minimum. If it is negative, then it is a maximum. Clear? Then it is a maximum. So if you sketch the graph of y equals minus x squared, okay, then it's clear that the coefficient of x squared is minus. So we are having a maximum. It goes in this way. So it goes in this way. So this is a maximum. So these two are the basic quadratic functions, y equals x squared and minus x squared. Okay, so let's try it in this way. Let's recall our memory. So it's not learning something, it's recalling a memory, yeah? Because these are not new things. Let's recall the memory on the memory of quadratic graphs what we have learned during, during our good O-level days. Not just right, during our O-levels. The best period of your school life, huh? O levels, grade 10 and 11. That now that is gone. I don't know how it will go with you, but for me, the best ever time period in my entire school life is 10 and 11. Like some might say, I need to go to the primary back, grade 5, grade 4, grade 2. But in those days, like it's nice. Like there no any responsibilities. You don't think about anything. But the thing you are not that mature. You don't think about the society that much too. You go in a school van, you go to the classroom, whatever the class teacher says, you do. You do you do it and you come back. But when you are coming this with this all these adolescents and this when you become from a kid you become a boy, no? So that is the age grade 8, 9, 10. Some are there who became like boys in even grade 5, 6. පොඩි කාලෙම ලොකු වෙච්ච මිනිස්සු ඉන්නවනේ. But normally you are a kid and from a kid you become a boy normally in this grade 8, 9, 10, 11 period. And later that boy becomes a gent and then that gent becomes a gentleman. So that is how you even in here like girl, what is any feminine word for kid? No. Kid is a gentleman. So kid becomes a girl, the girl becomes a lady, no? So what is the opposite of gentleman? So there's a problem. Gentleman, lady, woman. Okay. So like that is the period like where you become a boy from a kid. So that is the best period of your school life, O level period. Like now you might think still you have 2 years in your A levels classroom. So තව අවුරුද්දක් තියෙනවා කියලා. But when time spends, we will realize the best period was this O level days. Okay. Thank you very much. Okay. So first draw this one, y equals x squared and y equals minus x squared. Okay, silence. Just silence. Sketch these two, y equals x squared and minus x squared. Silence. You are done. Too much is. Okay. Now let's say we have been given this one. Y equals x squared minus 1. Silence. Wait. Now look at this. This is y equals x squared. No. So when this is y equals x squared and you have been given y equals x squared minus 1, that means this parabolic shape graph comes down by 1 unit. Clear? It's minus 1. So minus 1 means this exact y equals x squared graph comes down by 1 unit. It comes down by 1 unit, which means now this is minus 1. So this is the graph of y equals x squared. You don't have to write it again, minus 1. So similarly, if it is y equals x squared plus 1, what happens? What happens? The y equals x squared graph goes, hey, listen, y equals x squared graph goes up by 1 unit. So when it is x squared plus 1, that means the graph y equals x squared goes up by 1 unit. So this becomes 1. Okay, then sketch these two. Y equals x squared minus 1 and y equals x squared plus 1. Silence. කතා වැඩි ගියසද හොඳට හිටියා. ආයෙ බැනුම් අහන්න වෙන්නේ. Okay, so then we have y equals, let's say you're having minus x squared plus 2. So what can you say about this one? First we got y equals minus x squared is a parabolic shape graph with a maximum. So now it is plus 2. What happens? That graph goes up by 2 units. Clear? Same thing. The y equals x squared graph goes up by 2 units. So here we have the graph in this way. Okay, this is y equals. So this 2. So this graph is y equals minus x squared plus 2. Okay, then put number 5. Y equals minus x squared plus 2. Students who have joined online, if there's anything, if you want to get anything clarified, you can use the chat, YouTube chat. Because in the physical class, students can directly ask the question from me. I'll be checking the chat On and off, so you can send a message in that one. Okay. Okay, then start the 2017 A-level question. Start the 2017 A-level question. Silence, silence, do the work. If not, I can see the batches clearly. I'll be calling you by the names. School names, not your names. So 2017, you need to solve the inequality y equals x squared. Sorry, x squared minus 1 should be greater than this. So I told you we are using the graphical method. So if you go ahead with the graphical method, sketch y equals modulus x plus 1, which is x plus 1 and minus x minus 1. X is greater than minus 1 and less than minus 1. Okay, so here, first let's draw the quadratic graph that we know y equals x squared minus 1. So x squared minus 1 is a parabolic shape that goes in this way. So this is 1 and even these 2 points become 1 and minus 1. So if you're having any doubt that how did these 2 points become minus 1 and plus 1, this is how we take this. Look at the board. So y is equal to x squared minus 1. Okay, y is equal to x squared minus 1. Okay, now tell me at these 2 points, what can you say about the y value? At these 2 points, what can you say about the y value? It's 0. Clear? At the point that the graph is intersecting the x-axis, the y value, no, listen, look at the board. The y value is 0. So how can you take these 2 points? Now we got y is equal to this. And now when y is equal to 0, you have x minus 1 and x plus 1 is equal to 0. So you get two values that x is equal to 1 or x is equal to minus 1. So finding these 2 points is important because it's a turning point. So we need to know, okay, these are the 2 points, minus 1 and plus 1. And now draw the graph when it is greater than minus 1, you get this. And when it is less than minus 1, you get this. So what is this? It's y equals x plus 1 having a gradient of 1. And what is this? Y equals minus x minus 1. Clear? Okay, you're supposed to solve the inequality such that the quadratic is greater. So it's clear the quadratic, the black colored one is greater. In this region, it's greater. In this region, it's greater. In this region, the modulus, the blue colored one is greater. Again, after this point of intersection, again, after this point of intersection, this is greater. Clear. This one is greater. So we need to find this one. So it's clear this intersection point, you know, we need to find this one. We can now find this intersection point. Find this intersection point. What is this intersection point? What has been intersected? Y equals x squared minus 1 and y equals x plus 1 has been intersected. Okay, find this point of intersection, then you can write the answer. Okay. Okay, now listen. Silence, huh? Okay. So I told you we are supposed to find this intersection point. No. Silence, silence. Okay. So now when you find this intersection point, what are the two graphs that have been intersected? Y equals x squared minus 1 and y equals x plus 1. So when you make these two equal, we are getting this quadratic equation x squared minus x minus 2 is equal to 0. And when you solve this, you get x minus 2 and x plus 1 is equal to 0. So here it's x equals 2 and x equals minus 1. So what is the point that I wanted? It's clear that it is here. So out of 2 and minus 1, it's clear this should be a positive one. So here it's x equals 2. So look at this, something an interesting point. We need to think about this one. Now it's clear we get two values. And out of the two values, this is x equals 2. So that is clear. But we need to think, why do I get two values? Why do I get two x values as the point of intersection? Okay, now look at this. Here we have considered the intersection points of y equals x squared minus 1 and y equals x plus 1. So it's clear this parabolic graph and this straight line get intersected in 2 points. This is one point. What is the other intersection point? This is the other one. So that's why when we are going to find when we are just going to find the point of intersection, we end up with two answers. So we only want this one, that I admit, but we end up with two answers. The reason this straight line and the graph get intersected at 2 points, minus 1 and 2. But based on the position of this point, it's clear that it should be 2. Then you can write the answer. So what is the final inequality? You can write that x squared minus 1, the quadratic function, is greater than modulus x plus 1 when you can write the final answer. X is less or equal to minus 1 or x is greater or equal to. You have to consider the equality, no? The equality should be considered. Okay, hands up if that is clear. This one is. Okay, now start the 2015 question. 2015. Okay, silence. I gave a question. 2015. Silences. To the question 2015. Okay, so in 2015, we got the inequality modulus x is less than 2 minus x squared. So 2 minus x squared means that minus x squared plus 2 graph. So when you sketch these two, minus x squared plus 2 goes in this way. Clear? Here it's 2 and this one is y equals 2 minus x squared over the same thing minus x squared plus 2. So when it is in this way, it's clear that the minus x squared graph has gone up by 2 units. And then we have modulus x. So modulus x is y equals x and y equals minus x. Y equals x and y equals minus x. So you're supposed to find the inequality such that the quadratic is greater. So quadratic function is greater in this range. So find these two point of intersections. Inside this range, it's clear that the quadratic is great. So I'll find this one. So here, what is intersected? Y equals 2 minus x squared and y equals minus x. So minus x is equal to 2 minus x squared. When you take this to this side, it's x squared minus x minus 2. So you get x minus 2 and x plus 1. So I'm getting two answers. X equals 2 or x equals minus 1. So based on the position of the point, it's clear. So I have considered that these two have been intersected. So it should be a minus. It's clear you get minus 1. So even we get 2 and minus 1, this one should be a minus. So it's minus 1. And similarly, if you find this point of intersection, you get 1. When you consider y equals x and this, you get 1. So here, even though we get two answers, I can only get the minus 1. And next one, I'll even find this. What is the intersection point? We are considering the intersection of 2 minus x squared and y equals x. You get x squared plus x minus 2 is equal to 0. So it's x plus 2 and x minus 1 is equal to 0. So I get x is equal to minus 2 and x is equal to 1. So here it's clear that this one should be a positive. So I get the positive value. But again, I'm telling you, this is the thing we need to consider. Look at this. Look at the board. Look at the board. Okay. So here I have considered the intersection of y equals minus x and y equals 2 minus x squared. And I get two values. So according to this one, I get two intersection points. Okay, now come to here. Now here it's clear. We get two intersection points, and in the diagram, you can clearly see two intersection points. We get x equals 2 and we get x equals minus 1. So in the diagram, you can see the two intersection points. Is it clear? When we solve this using algebraic means, we get two intersection points. In the diagram, you can see the two intersect. Hey, wake up, wake up. Okay. In the diagram, you can see the two intersection points. But now there's a problem here. No? We have two intersection points. When you solve this using algebraic means, we get two intersection points. But in the diagram, so what I have considered is y equals minus x and y equals 2 minus x squared. I only have one intersection point. You can say, sir, yeah, there are two, not these two. Because I'm referring to the intersection of y equals minus 6 and this quadratic graph. So we get two intersection points, but in the graph, it's only one. So what can you say about the other intersection point? The reason is this is not y equals minus 6. I am the one who have restricted or stopped the straight line from here. Because in the modulus, this y equals minus 6 is only valid when x is less than 0. So that's why I have stopped it here. But if you consider the original y equals minus x graph, this one will be continued in this way. And here you get the other intersection point. You get the other intersection point, that is x equals 2. But we only get one intersection point because we have limited this y equals minus x graph up to this point. We have limited this y equals minus x graph up to this point. So that's why you can only see one intersection point. But when you're solving it in algebraic means, you get two intersection points because there is another intersection. Okay. As Abu got this answer, x is, no, wait, you have to write the final answer. Modulus x is less than 2 minus x squared when x is greater than minus 1 and less than 1. Has Abu got this answer? Okay, good. So we are still in the topic how to sketch quadratic functions. How to sketch quadratic functions, and we did few questions. So far we have learned, we have recalled the memory of sketching y equals x squared minus x squared minus 1 plus 2. In that way we know. Okay, so now I want you to do this one. So everyone here most probably have got a or B pass for O-level maths. And even though you have got a C pass, that is okay. Because getting a C pass means you know more than 50% of the syllabus. But most probably many students here have taken either A pass or B pass. So what I want you to do is using your O-level memory, we drew five graph, no, 1, 2, 3. Yeah, we have, so far we have drawn 5 graphs. I need you to sketch the graph of y equals x squared minus 2x minus 3. Karan ba? Sketch the graph of y equal. No, silence. Tadi yang Karan. Not using the table. Table means minus 3, minus 2, minus 1, 0. A वगैरह देखा मान panti. No, not here. So you can use the table. Because you have done this method. I need you to draw the graph of y equals x squared minus 2x minus 3. Silence, silence, silence. Sadanatan. Silence, I didn't ask you to discuss anything using your level knowledge. Sketch the graph of this given one, the given one. ඕන්න එක බලලා වෙලා තිබ්බොත් graph එකක් අඳින්න. නෑ ඒක බලන්න බලන්න reply එක දාන්න. ඒක reply එක දාන්න බෑ නැත්නම් අන්තිමට graph එකක් නෑ ඒකත් නෑ අන්තිමට. Okay, listen, listen. Now look at this. Now listen carefully. දැන් වටපිට බලන්න එපා. අරේ ආමරණ අරුටත් ඒ මුටත් ඒ මටත් ඒ හැබැයි උන් දෙන්න ඇඳලා මං ඇඳලා නැහැ. Okay, look at this. Look at the border. Small thing I'll explain. So first thing, there are only two, like when you are drawing a graph quadratic function, we only want two things that you need to find. One thing is if it is a minimum, the lowest point. If it is a minimum, you have to find the lowest point. So to find the lowest point of a quadratic function, the lowest point and the symmetrical axis. Because we know the parabolic shape is symmetrical. So how, the first thing that you need to find the symmetrical axis of the graph and the minimum. So if it is a minimum, you have to find the minimum. If it is the maximum, you have to find the maximum. So how can you do that? What you have to do, you need to complete squares. So when you complete squares, you get x minus 1 because I'm not going to explain how to complete squares. So x half of this minus 1 squared, you have put a 1 minus 1 minus 3. So when you have x minus 1 squared minus 4. So when you complete squares, just keep this in mind. This x equals 1 becomes the symmetrical axis. X equals 1 becomes the symmetrical axis. And this one becomes the minimum or the lowest point. So number one thing that you need to complete squares. So when you complete squares, this becomes the value that this becomes 0. The value that this becomes 0. So this becomes 0 when x equals 1. Now that is the symmetrical axis. And minus 4 will be the lowest point. Minus 4 will be the lowest point. So how do you mark it? So this is how you mark it. When x equals 1, I get the symmetrical axis and the lowest one is minus 4. Which means your graph will be going this way. That's all. Your graph will be going in this way. So after getting the lowest point or the minimum, you can sketch the graph in this way. And for additional data, you can mark these two. So I explained that. So how you can get that one, the intersection points of x-axis, intersection points of the x-axis, intersection points of the x-axis. So I told you at these points, the y coordinate is 0, so y becomes 0. At these points, y becomes 0. So you can easily get these 2 points by solving this quadratic equation. This is equal to 0. You get x minus 3 and x plus 1 is equal to 0. So what are the 2 points? X equals 3 or x equals minus 1. So that's all. So when you know this, then this is minus 1 and this becomes 3. This is more than enough to sketch a quadratic graph. That's all. You don't have to draw this table minus 3 plus 3 minus 2. No, that is not necessary. Complete squares. The x value that makes this 0 is the symmetrical axis. And this is the lowest point or the minimum. And when you make this function equal to 0 and solve it, you get the 2 intersection points. And there is an additional point, you can get this one. If you consider x equals 0, so when x equals 0, this is 0, 0 and minus 3. So this point is minus 3. So that one you can easily sketch. Okay, hands up who can remember this? Who can remember this? Okay, good. Never mind. So like if you can't, even if you can't remember, that is totally fine. I explained it how to do this. Only 2 things you have to do. Complete squares and factorize. Okay. So write in this way, to sketch the graph of a quadratic function, to sketch the graph of a quadratic function, to sketch the graph of a quadratic function, we need to find, we need to find the symmetrical axis. We need to find the symmetrical axis, comma, minimum slash maximum, minimum slash maximum value, and the intersection points, and the intersection points of the x-axis, intersection points of the x-axis. Okay, then do this complete squares. So here it's clear this becomes 0. The x value that makes this one 0 is the symmetrical axis. So here it's the symmetrical axis. Because you can see here, you can see clearly the graph is symmetrical beside this axis. So this is the symmetrical axis. Okay, so after this, everyone do draw the graph of y equals x squared minus x minus 2. Y equals, listen, y equals x squared minus x minus 2. Same way, complete squares, find the symmetrical axis and minimum, and then you can factorize and get the point of intersection. Silence, do this. A small thing, same thing. Complete squares, find the symmetrical axis over the axis of symmetry, the minimum, and the intersection points. Okay, so here, first thing you need to complete squares. So when you complete squares, you get half of the coefficient of the middle term. So half of minus 1 is minus half squared. Silence. So what do you put inside to this? It's you have x squared, you have minus x, but the square of this, so minus half, you have to take it out, minus 2. So when you simplify, you get x minus half squared and minus 1 over 4 minus 2, which gives you minus 9 over 4. So when you simplify, you get minus 9 over 4. So I told you the axis of symmetry is the x value that makes this 0. So it's x equals half, and this one becomes the minimum. So this becomes the minimum. To find the point of intersection with the x-axis, make this equal to 0. So when you make this equal to 0, it's x minus 2 and x plus 1 equals 0. So x equals 2, O, x equals minus 1. Okay, then you can sketch the graph. The symmetrical axis is half. The lowest point is minus 9 over 4. So it goes in this way, the parabolic shape. So what are the 2 points of intersection? This is x equals 2 and x equals minus 1. So I told you can easily find the intercept by considering x equals 0. So when x is equal to 0, it's 0, 0. So this is minus 2. So this is minus 2. How can you get it? By considering x equals 0. Okay, hands up who got this graph. The intersection points minus 2, 2, sorry, minus 1, 2. Symmetrical axis is half and the lowest is minus 9, 4. Hands up who got this. Okay, good. I'll give you 1 minute, drink some water. Okay, okay, write the topic. Write the topic. Write the topic. Graphs of special modulus functions. Write the topic. Graphs of special modulus functions. Graphs of special modulus functions. Okay. Okay, so now turn to the second page of the modulus graph tute. In the main tute, it's page number 18. So everyone is supposed to have the main tute. No, even in the paper, it's even the second one. So here, question number 3, you can see sketch graphs of the following special modulus functions. And it's clear every modulus function is quite different from the modulus functions that we have sketched so far. So I think we have sketched more than 40 modulus functions so far, including past papers. But in this question number 3, what you see is all the functions are different from what you have sketched so far. Okay. Now I'm referring to question number 11. We need to draw the modulus of this. So we need to draw the modulus. So here, main question, question number 3. And so we need to draw the modulus of this. Okay, now listen, a small thing, because we have done 80% of the work we have already done. Now listen. Okay, sit properly. Can't sleep. Huh? Look at the board, focus. Because that's why I gave you some time to drink some water. Even you can just wash your face, that is okay. You can bring wet tissues or in something. You can keep wiping your face so you won't sleep. Hey, killing PVR again. Okay. Now this is the thing. Okay. Now we are supposed to draw the modulus of this. So when you have to draw the modulus of this, first what you have to do is draw the quadratic function y equals x squared minus x minus 2. So that we have done. Now tell me, what is the modulus of 2? What is the modulus of 2? Modulus of 2, it's 2. Modulus of minus 2, it's even 2. So it's clear, if it is a positive value inside the modulus, the sign won't change. You will be getting directly the exact value 2. Modulus 2 is 2. But what does a modulus do? If it is a negative inside the modulus converts the negative to a positive and give that value. So that's why minus 2, the modulus of minus 2, you get 2. So is it clear? So what is the task of a modulus? If it is a positive, if it is, okay, if it is a positive inside the modulus won't do anything. Directly, the modulus will put the value out. But if the value of the value inside the modulus, if it is negative, what does the modulus do? The modulus will convert it into a positive and give it out. Clear? So how can we like that we discuss? How can we convert minus to omega no atradena? So when you like, how can we convert a minus 2 into plus 2? How did the modulus, we discussed this, how did the modulus convert the minus 2 into a plus 2? By multiplying by minus 1. Because when you multiply a minus value by minus, you end up with the positive 1. Okay, now look at this. This is the graph of y equals x squared minus x minus 2. And I need to find the modulus of this graph. So now it's clear, this is the graph y equals x squared minus x minus 2. It's clear. Now I need to find the modulus of this. So when you consider the modulus of this part, since it is positive, It's clear there won't be any change. Since this is positive, there won't be any change. If you consider the modulus of this part, what do I mean by it is positive? Because it is above the x-axis. When it is above the x-axis, it's positive. When it is below the x-axis, it is negative. So when you consider the modulus of this, there won't be any change because it is positive. Positive values will remain in the same way. But now look at what happens here. When you consider the modulus of this negative part, this one should be converted to the positive side. No? So this negative side, when you go through a modulus, this negative should be converted into a positive one. So if you think about this value, what is the modulus of minus 9 over 4? Tell me, what is the modulus of minus 9 over 4? Plus 9 over 4. What is the modulus of minus 2? Plus 2. So what happens? The negative side of this graph will be reflected to the positive side, will be mirrored to the positive side. So what happens here? Because the modulus won't interrupt in the positive side. Positive side but what happens to the negative side? The modulus will mirror this negative side to the positive side. This will mirror the negative side to the positive side. So first you need to sketch the exact quadratic graph, and then you need to mirror the negative parts to the positive side, and you will be getting, okay, now this one is minus 9 over 4 becomes plus 9 over 4, minus 2 becomes plus 2, minus 2 becomes plus 2, minus 2 becomes plus 2. Okay. So the most important part is getting the equation. So here the name or the equation of the graph. So this is y equals x squared minus x minus 2. This is y equals x squared minus x minus 2. So what is this? This is even y equals x squared minus x minus 2. It has been converted to the positive side. I told you, how can you convert a negative number, negative value to a positive one? You have to convert it by multiplying by minus 1. So here, this is y equals x squared minus x minus 2. So when you multiply by minus, you get the positive side. So this is y equals minus x squared minus x minus 2. So this one is y equals minus x squared plus x plus 2. Okay, so this is the negative of this one. So this graph is y equals x squared minus x minus 2. So when you multiply by minus, you get the positive side. So this is mirrored to the positive side, but the equation is the minus of this graph, the minus of this. So this shape, this graph. So you can see this graph, this shape, this one, this one, this one, which looks like a Batman. Not like Batman, no, looks like a Batman from Daras. No, not Batman like this shape. Batman just came to my mind. Pasti tu naik Batman me mana ni Daras taking lagi Batman gattu. Okay, so this shape is the modulus of x squared minus x minus 2. So this one, this graph is the modulus of the quadratic one. Okay, small thing. So what do you have to do when you are supposed to sketch a modulus function, modulus of a quadratic? First draw the quadratic one and mirror the negative side into the positive side. Hey, Nidhi. Mirror the negative side to the positive side. But when you're mirroring, make sure that even the equation change. This is the original x squared minus x minus 2. So this part becomes the minus of that. Is it clear? Okay, hands up if this one is clear. Okay, the thing is, but they haven't asked to sketch quadratic, the modulus of a quadratic function. I think last there was one question in 1990 someone. After 2000, they haven't asked this, but we are from, we means most of the physical, not everyone from the physical class is from Colombo. And you will realize how do you get this Colombo school term test. Mainly the Colombo school term test are not prepared for the students. So that happens. The Colombo School term test papers, especially in the science stream, those are not compiled for students. So those are compiled to show the capability of all the teachers. So when you have to do these questions, these will be quite normal. But in A levels, this haven't been asked after 2000. But when we do a question, we can't learn. දෙදාහෙන් පස්සේ මේක ඇවිල්ලා නැහැ මේක අහලා නැහැ. We can't learn in that way. We have to complete the entire lesson. So when we know the entire lesson, then from any point they can ask a question, even in the A-level paper or in the term test, you will be able to answer. Or if not, let's say we are doing modulus function for 4 weeks, and you go to do your school exam paper, you get a, and I'm not doing this part. I'm not doing this part. We all are lucky. You get a modulus function of a quadratic in your term test paper. Then you will be reminding me and my parents, grandparents, all them, because we have been doing modulus functions for 4 weeks, but yet we haven't done this part. Okay, so that's why when we are learning, even other two subjects, maybe physics, chemistry, ICT, when you are learning, don't learn anything expecting this haven't been repeated after 2011. If it is in the syllabus, we need to learn every point of that one. We need to be 100% crystal clear with everything in the syllabus. Because then, like, let's say we are getting this question in the 2027 paper, because you are so lucky. And then can we challenge, this is not in the syllabus, this haven't been come from after 2000, දෙදාහෙන් පස්සේ ඇවිල්ලා නැහැ. 21 වෙනිදා නුගේ කොට එන්න මේක ආවේ නැහැ දෙදාහෙන් පස්සේ. We can't say in that way, is it clear? So that is not practical. So we need to learn everything in the syllabus. So that's why we are covering every part of this one, even the special modulus functions. Okay, okay, then so we have this topic, special modulus functions. Under that, put using a black pen, put number 1. Okay, put number 1 using a black pen, write this. Modulus graphs of quadratic functions. Modulus graphs of quadratic functions. Modulus graphs of quadratic functions. Okay, so write in this way. Write in this way. When we have to sketch, the modulus graph of a quadratic function, when we have to sketch the modulus graph of a quadratic function, first we need to sketch the quadratic graph. First, we need to sketch the quadratic graph. Then write in a black pen the negative part of the graph. Then the negative part of the graph should be mirrored to the positive side. Should be mirrored to the positive side. Okay, so then consider this one. You don't have to draw this from the beginning, just replicate the same graph you just drew. So put number 11, question number 11 in question number 3, and draw this. Now after this, draw the modulus of the graph that we have taken before, x squared minus 2x minus 3. Draw the modulus graph of this one, because we have already sketched the quadratic graph of this. Silence. So do this, first do this. So the main thing is write in the equation, because even the equation get minus. So after this, draw the modulus of this one, draw the modulus of this one, and you can directly get the graph because we have drawn that before. Students who have joined online, can you send me a message in the YouTube chat? I need to make sure whether you can message there because I got an inquiry that they are not able to message there. Can you, if you are following the exact live, can you send me a message mentioning clear, or anything? So I just want to verify whether you can use the chat, the live chat. And there was a question that when you are drawing the graph, you don't have to draw this according to exact scale. These all are rough diagrams. So you don't have to draw this using a scale because these are rough diagrams. Can you, can, no? No, just send any message, you can put clear, so can, no, it's possible. Okay. So when you're sketching the graph of y equals x squared minus x minus 2, so I'll use what we got before. The symmetrical axis was 1 and the minimum was minus 4. It's minus 4. Silence, silence. And this became 3 and this one was minus 1. And the intercept became minus 3. So this is the graph of, so the equation here, it's y equals x squared minus 2x minus 3. So when you want to find the modulus of this quadratic, what you have to do, you need to mirror this one. You want to mirror this one to the positive side where minus 4 becomes plus 4. Minus 4 becomes plus 4 and even minus 3, that becomes 3. Okay. So one main thing that I want to highlight, I told you the how do you write the equation? It's always the minus of the original quadratic function. Minus of the original quadratic function. The part that you have mirrored is the original. So minus x squared plus x plus 2. So this graph is the modulus of y equals x squared minus 2x minus 3. Okay, got it. Okay, this one, the equation. So it's minus 2x x squared minus 2x minus 3. So we get plus 2x plus 3. Clear. Okay, hands up if this quadratic modulus graph or the modulus graphs of quadratic function. Hands up if this is clear. Okay, take a break and come by 5:30. Okay, then write number 2. So we are under the graphs of special modulus functions. And then put number 2 using a black pen and write this. Graphs of functions. These graphs of functions consisting of a modulus. Graphs of functions. Graphs of functions consisting of a modulus in a modulus. Graphs of functions consisting of a modulus inside, wait, a modulus in a modulus. graphs of functions consist in a modulus in a modulus. Okay. Okay. So now look at the same question, question number 3, and look at the first graph. You're supposed to draw the graph of y equals modulus, a modulus x minus 2. Okay, now listen. So it's clear. Inside the modulus, there is another modulus. So inside the modulus, there is another modulus. So in this case, to sketch the graph of this, I'll be getting the help of what we learned previously under sketching the modulus of a quadratic function. Okay. So first thing what we have to do here, I will be drawing the graph of y equals modulus x minus 2. Okay, so first thing I'll be doing here, I will be drawing the graph of the function that is inside the modulus. So first sketch y equals modulus x minus 2. Silence. So I know how do we get this? It's x minus 2 and minus x minus 2. When x is greater, no, silence. X is greater or equal to 0 when x is less than 0. Okay. Okay, then first draw this graph. Y equals modulus x minus 2. So you get the intercept when x equals 0, it's minus 2. This and this. So what is this? It's y equals x minus 2. What is this graph? It's y equals minus x minus 2. Okay, now listen. So we are in here. So we are inside the question number 2, the special modulus functions. So now I'm referring to a function where we got a modulus inside a modulus. Now it's clear. We have this modulus and inside that there is another modulus. So how am I going to sketch the graph of this now? Okay. 9. Okay. So how I'm going to sketch this one? First thing, I want you to sketch the graph of the function that is inside the modulus, which means this modulus x minus 2. And you get, okay, this is the graph modulus x minus 2 that we have drawn because we have done every type of a normal modulus graph. So these are special cases. No? So we know how to sketch any modulus graph up to now. Okay, so first do the definition and then you can do this. Okay, now this is how we learn maths. Okay, now I told you this modulus function, the inequality question started to change from in 2019. Till 2019, what we have to do the same thing. We had to sketch the two modulus graph and then you have to solve the inequality. But in 2019, you can remember, they introduced this substitution thing where you had to use a substitute. So either you have to put x instead of x, you have put in 2x. It can be x over 2, it can be x is replaced by x plus 1, x is replaced by 3x. It can be any substitute. You can't say that you are only getting either x is replaced by 2x or x is replaced by x over 2. It can be any substitute. It can be x has been replaced by x minus 2, x plus 2. So like I started classes for the first class was 2022 batch. No, the previous I was only doing individual classes, and individual classes is something different. That is something most of the university students, state university students do to get an income during their university period. So doing individual classes is a support because very rarely there are students who are only totally dependent on the individual class. So normally when we are going for this individual tutoring, every student is attending a normal group class or a hall class. So they need some additional support. So when I'm doing individual classes, that is a different story. So my first group class, the hall class was the 2022 one. So that we started in 2020. So 2022 means you are 2027. We started it in 2025. So when I started classes in 2020 for the 2022 batch, so then when we look at the past papers, it's clear 2019 there was a substitute. 2020 there was a substitute. So even before going to the 2022 paper, When we were doing the 2021, even in the 21 paper, we had to use a substitute. So now, like it's clear, for 3 consecutive years, we had to use a substitute. So then normally as tutors, what we do, we teach or we explain the every possible substitute that you can get to the get for your A-level paper, for the 2022 A-level paper. So we practice x is replaced by x over 2, 2x, 3x, x over 3, x plus 1, different substitutions. But when it came to the 2022 paper, it was a completely different graph. And this was this graph. They had to sketch the graph of y equals modulus inside this modulus. So this is the thing what happens. But when I ask, when students come after the A-level exam, but I admit that the majority of students were having problems how to sketch this graph. But there were some students who use their knowledge on what they know and they have applied the same thing in this. Because I told you in before the 2022 exam, not only me, any of the tutors haven't explained how to sketch the graph of this. Because that was not in our frame. But everyone, including me, we have explained how to draw the modulus function of a quadratic one. So in that one, we learned how to sketch a quadratic modulus function. First draw the quadratic function, and then you have to mirror the negative part. So here, what the students who have done this question properly in the 2022 exam, they have done the same thing. So what they have done, first they have drawn the graph inside the modulus. And then, since we are referring to the modulus of this negative part should be, the negative part should be mirrored to the positive part. The same thing what we just learned. So based on that, here you can get this is 2. So how did this become 2? When y is equal to 0, this is 2. When y is equal to 0, this is minus 2. So then what happens? This negative part is mirrored to the positive side. This negative part is mirrored to the positive side. Same thing. Same thing. This becomes 2. You know how to take the equation. How can we take the equation? This straight line, y equals x minus 2 straight line. This is the straight line that has been mirrored. No, this is the straight line that has been mirrored. So I told you, how can we mirror this? We have to multiply this by Solunga. We need to multiply this by minus. So what is this one? It's y equals minus of this x minus 2. That is y equals minus x plus 2. And what is this one? This is the graph that has been mirrored. So that we have to consider the minus of that. So what is this? Y equals minus x minus 2. The minus of that gives you y equals x plus 2. So same thing what we did before. Draw the graph inside the modulus, main modulus, and then mirror the negative parts to the positive part. So I told you in the A-level exam, there were some students when they came, like that was not a big batch in the Sinhala, only class was the Sinhala medium class, and there were around 100 students, 100 or 110 students in that class. So like let's say after the exam that the every 110 student won't come and talk to me, roughly around 80 come. So when 80 came and talked with me around, I can't remember exactly because this is back 5 years back, but roughly around 50 of the students told me, I didn't get any idea how to draw this modulus graph. But there were like 30 students who gave this. So using the knowledge of these quadratic functions, I drew the graph. So what they have done here, they have used the knowledge of quadratic modulus functions, drawing this one initially, and then mirroring the situation. But the thing that happens, like you have already done O levels. Now, when I'm telling you this, you will realize, okay, it's a small thing, or panas dena mana mode you need. You might get in that feeling. Why couldn't that 50 students who were not able to do that question? Why couldn't do that? Why couldn't they do that? So that is the mindset. Slowly and gradually, we need to develop for our A-level exam. Because when you are doing this A-level exam, it's full of tension. You had that tension at the initial papers of your O-level exam. Till the first 2-3 papers, you had that tension. And then you realize this is same as the term test. This is same as the papers, past papers, same as what we learned. Then when you go to the later part of the exam, then you are waiting till this is over. You are not like when you're writing the paper, you don't have that initial tension that you had in the later papers, you don't have. But in the A level exam, just think we are going for classes for 2.5 years. You are roughly going for 2 years and 3 months. You go for classes. A classes is a minimum of 4 hours. No? Okay, it's a minimum of 4 hours. You go to school for like one year, 1.5 years, you go to school for this A level exam. And when it comes to this A level combined maths paper, the paper is just 6 hours and 20 minutes. So you have been going for classes for 2 years and 4 months, like a minimum of 4 hour classes for one subject, and you are going for 1.5 years for school to do this paper, which is inside 6 hours and 20 minutes. So you know the destiny in your A level destiny, not the destiny of your life. The A level, but the A level destiny is the destiny of life of many people. So your destiny of this A level depends on 6 hours and 20 minutes. So that is even less than 2 class sessions. That is even less than 2 class sessions. So you have this tension. So when this paper, when these questions, different questions comes with a tension, it's hard. It's really hard to think inside the paper and then get this graph done. So that's why you might say, sir, when I was leaving the school, when I was coming back to home, I just realized, okay, this is how we are supposed to draw this. But then there's no any use that you are realizing the way to do that question on the way to home. No? You're supposed to do that when you're doing the paper. No? So I'll tell a small incident. Even though so we are doubt in our knowledge. So let's say you did this, but you are not sure about this. So even a student who is very well capable of maths, after doing this, he think, am I correct? So he's just asking from someone, are you there? Yeah, you ask that. We do that. Okay. So even when I was doing O levels, the thing that I had in O levels and even A levels, if I'm having a doubt, that is a doubt for everyone. So then there was no one that I could ask that. So I was having that in every exam. So only when I went to the university, the things changed because university all are big brains are coming. So then if I'm having a doubt, all the others are not having the doubt. So we can discuss if we're having not inside the paper. But in the O level and A level exams, if I am having a doubt, the entire section is having a doubt, the same doubt. So I can't clear it. So that happened. Hands up who did commerce for O levels? Commerce, it's as accounting and business studies. Okay, so hands up who did commerce in English medium? Okay, so okay, good. Because when we were doing commerce, there was no any English medium commerce for O level. So I did in Sinhala. So in commerce, you have this profit and loss account. You have this profit and loss account. No? So when we are preparing this profit and loss account, the syllabus that we were doing, I did O levels in 2012. So that syllabus was started from 2008. So I have done all the past papers from 2008 up to 2011. All the past papers and even so many model papers. So in every profit and loss account, the final answer was a profit. In the O-level paper, we got a profit. Every term test, every O-level, previous O-level papers, model papers, provincial papers, anything, continent papers, got the eight, you get a profit. So when it came to our O-level paper in 2012, I just made the calculation. I got a loss. So it's not a profit, it's a loss. So like even though I was very good in commerce because I even got the commerce subject prize in grade 10 and grade 11 prizes are based on the O-level exam. So grade 10, I got this like in our school, we get subject prizes and all the prizes only for the last term test. Because some schools, they are considering the average of all the 3 term tests and giving in our one, it's only the last term test. So I even got the commerce prize. So what did I do? I again calculated and check whether I have put in the proper columns or in this way. Again, I got a loss. So I'm having the doubt. So I was very good in that part, but I'm having the doubt. So what did I do? I was just looking up and there was no one. There was one student, I still can remember his name is Ranusha and he's now living in Canada. He's a real estate agent in Canada. So, and he like, we know students like, even he is not the first, second, third in the class, but he is good in commerce. There are students like that, no? That they are not in the top positions of the class, but they are good in different subjects. For example, the one who was behind me is good in English. He was superb in English, and now he's even an English compeer. And he even read news for Channel I, and he was superb in English, but he was not in the top 3. So when I was looking at him, then he saw me, and then I just asked him that whether you got a loss singling and then he haven't made by then he hasn't completed that one. Then he just waited, and then after like 30 minutes, he told me, and when I just look at this and not do you must be thinking, no, sir, O level කතා කරාද? ඕක කතා කරේ නැහැ. I know how you do exams, no? So, so then he was like telling me, like, මටත් ආවේ අලාභයක්. So he told me that he even got a loss. And even he told me at the end of the exam, අර හොඳලාට උඹ කිව්වේ නැත්තම් ඔක ආපු ගමන් උඩ යනවනේ කියලා. මම උඩ ගියා. හරිද? මම උඩ ගියා, but I didn't have anyone to ask that question. And the funniest part of that one, so there are only 20 students in one classroom. 20 students, no, it's I don't know whether the arrangement has been changed, but 5 students per row, and you have 4 rows in one. So 20 is the maximum, I guess. So there were 20 of my class students, and the next class there was the remaining 20. And the invigilator, the examiner in the next classroom, that he was from Nalanda, and he was a good like, and by then, and commerce is at the end of, I think, after completing 6 or 5, 6 subjects, we have commerce. So the students of them has been friendly with the examiner. And one student has told that examiner that he is a sir from Nalanda. So එයා පන්ති මණ්ඩප කියලා එක්කෙනෙක් ඉන්නවා මේ පොඩ්ඩක් අහන්න පුළුවන්ද මේ බලාපු කෙනෙක් මේ ලාභයක් දෙන්න කියලා. So someone has asked from that sir, by then he has become like friendly with the students. So he came, like, I don't know that someone has asked from him, but later the person who asked the question, that he came to me and spoke with me. Then only I know that I can't see what is happening in the next classroom. So then this sir came and he was standing right in front of the door. Section that he was starting in front of the door, and then I was in this corner. Corner means the last row of the classroom, but I was one before last. I was here. And then suddenly he looked at me and asked, like, say, like he came to the near to the door of the classroom, and he has asked from the student, who is Mandaba? Then he can how the Mandaba. I say, Aru Benalama. He showed me. And then he looked at me, like, I'm writing the paper, and I go, Mandaba, go Mambelo. And he was in front of the classroom. From there, he asked me, Labalabu Kirume, me Alaveda. So he asked me, in the profit loss account, did you get a loss? So then I said, yes, sir. I saw this every evening, most of the students. So everyone was having that doubt. So everyone of the classroom was having that doubt that everyone has got this loss, and they were looking here and there. And then I gave the confirmation, yeah, it's a loss. Then it's like Sanasum Susuman Wage, everyone was okay. Okay, so I was just telling this story. So that is, okay, silence. So that is this exam mentality. How capable or how knowledgeable you, how much you have practiced. If the structure changes in the paper, we are doubting about our knowledge. So that's what we have to gradually, that component, trust in your knowledge, trust in yourself, that component we need to gradually develop throughout these 2 years. Because when you go to the paper, you don't get an exact replica of the past 5 papers. There might be questions, 2, 3 questions, which has been deviated from the normal structure. So we need to make sure, if you know the theory, you can do that question, but you need to make sure that you need to be confidence about your knowledge. So here, the same thing that they have applied. First, we have to sketch the graph inside the modulus, and then the negative part should be mirrored to the positive one. And make sure you put the proper equations. Here, this straight line has been mirrored, so the minus of this. Here, this straight line have been mirrored, so the minus of this. Is it clear? Okay. Then number 2, I gave the topic. If anyone who got late, number 2, it was graphs of functions consist in a modulus in a modulus. Graphs of functions consist in a modulus in a modulus. Okay, then under that, write in this way. Same as in the previous way, same as in the previous, same as in the previous method, same as in the previous method, same as in the previous method, we will be drawing the graph. We will be drawing the graph of the function graph of the function inside the modulus, inside the modulus, and and the negative paths and the negative paths will be mirrored to the positive side. The negative paths will be, with the negative part will be mirrored to the positive side. Okay. Then do this question y equals. So it's the first question and question number 3. First question and question number 3. So after this, do the second question. So let's do this. So make sure you put the equations properly because we need the equations. Now after this, do the second question. So next week we'll be starting applied maths, the other component of combined maths, and we are starting with vectors. Then do the second question, modulus x minus 1 minus 1. So here first draw the graph y equals modulus x minus 1 minus 1. You get x minus 2 and you get minus x. You get minus x. So this is when x is greater or equal to 1. This is when x is less than 1. Silence, silence, can't talk. So when you draw these two, so it's x equals 1. Find the turning point. When x equals 1, it's minus 1. So starting from here, you got x minus 2 and minus x. So minus x goes through the origin. You have to consider that. And this is y equals x minus 2. So that is x minus 2 means this is 2. So how did I get that is 2? This becomes 0 when x is equal to 2. And what is this? It's y equals minus x. So here it's clear when you consider the modulus of this, the negative part should be mirrored to the positive side. Minus 1 becomes plus 1. So take out this part. And the main thing is naming the equation. So what is this? Look at this. What has been mirrored here? Y equals minus x. So consider the minus of that. Consider the minus of that. It's y equals x. So what is this? What has been mirrored is x minus 2. So the minus of that, you get y equals minus x plus 2. Clear. Okay, so this graph is what you get as the modulus of the modulus x minus 1 minus 1. Class Tamil part. Okay, to the fifth one, question number 5. So what should be mirrored is the negative parts. In the question number 5, you are having two negative parts. Those two should be mirrored. Okay, so here, first we are supposed to sketch the graph of y equals 2 minus x minus 1. So I'll directly write the two graph. You get minus x plus 3. And then the other one is x plus 1. Okay, because we are in the fourth day, so I don't have to go step by step to show what are the two straight lines you get. One is minus x plus 3. Other one is x plus 1. So this is when x is greater or equal to 1. This is when x is less than 1. Okay. So first draw this one, you know the shape will be an inverted B. So at x equals 1, this one gives you plus 2. At x equals 1, this one gives you plus 2. So from here, draw minus x plus 3 means it goes in this way. And here it's x plus 1 starting from here. Yes. So when you're naming this is y equals minus x plus 3. And this is y equals minus x, sorry, x plus 1. So these points are important because those are the points that it will be mirrored. So this one, how do you take this? When y becomes 0, this is 3. When x becomes 0, this is minus 1. So now it's clear, not this one. This is anyways positive. No, this negative part should be mirrored to this side. And this negative part should be mirrored to this side. Please, you don't get this one. Make sure you write the proper equation. So here what has been converted to the negative side are this one has been converted. This has been converted. So it's the minus of x plus 1, which is y equals minus x minus 1. This straight line has been mirrored to the positive side, minus of that, minus x plus 3. So this is y equals x minus 3. Clear, this is y equals x minus 3. So this graph is the modulus of this. Okay, hands up who got this one proper. Okay, now do the 2022 question. 2022 A levels. When you're doing this, you don't have to go from the beginning. You're supposed to draw this exact one. You can use this graph directly. Hey, Kelim Mandina definitions unknown. 2022, you're supposed to draw this. You can use this. Okay, so if there's any doubts, you can ask from me and online students. If there are any doubts, you can drop a message in the YouTube chat. Any doubt regarding today's session? So do we need to maintain a separate book for applied maths? Yes, for applied maths, you have to start from a new book. Silence, silence, silence. For applied maths, you have to start from a new book, and like you don't have to buy a new book for new lesson, but write all the applied lessons in one book. Not you can't write in one book. Keep separate books for applied and separate books for PU. So when we will be doing the second part of trigonometry, that is, yeah, most probably we'll be starting the second part of trigonometry in December. We can do the 2022 question. And if there's any doubts, you can ask from me. So 2022, you don't have to draw you have to go from the beginning when you're supposed to draw modulus x minus 2. You can just copy the same graph. Okay. Okay, so I told you to use the same graph. Use means copy the same graph that we drew as the first one under this category. Y equals modulus, silence, silence, silence. Array silence. Modulus inside, you got modulus x minus 2. So I'll be using this. No, silence. So I know all the equations. So I'll only write the answer. Answer means the final answer. So this is y equals x plus 2. This is y equals x plus 2. And this is y equals minus x plus 2. Okay. And in the same graph, you're supposed to sketch y equals no, 2 minus x minus 2. Y equals 2 minus x minus 2. So here you get minus x. So here it's minus x plus 4. And here it is x. So when you sketch it when x equals 2. So that's why, look at this silence. So that's why marking these small details are important. Because the turning point of the next graph becomes x equals 2. So that's why marking them are important. Now you know when x equals 2, it's even 2. So it goes from this point. And after 2, you have to row minus x plus 4. So minus x plus 4 means it's going in this way. And the other one is y equals x. When x is less than 2, it's y equals x. It goes in this way. So this is the graph of y equals x. This is the graph of y equals minus x plus 4. And find the intersection point. So that's why knowing the equation of each straight line segment is important, because to get this point of intersection, you clearly should know what are the straight lines that have been intersected. Without knowing the equation, you can't get this. Even here, to write the point of intersection, you clearly should know what are the straight lines that are intersected. Okay, so I'll take this one. What are the two straight lines? Y equals minus x plus 4, y equals x minus 2. X minus 2 is equal to minus x plus 4, which gives you 2x is equal to 6. You get x is equal to 3. So when you consider the intersection point, these two, this is 3 and this is 1. The question that they're asking, the inequality, okay, modulus x minus 2 plus x minus 2 modulus is less or equal to 2. And I told you, you have to rearrange the inequality such that you are having the two functions that you have sketched on either sides of the inequality. Okay, so this is one function, this modulus this. So the blue colored one should be greater. So here it's clear the black colored one is greater. A blue colored one is great in between this range. Only in between this range, the blue colored one will be greater. So then you can say, okay, this is when x is greater than 1 or less than 3, equal or greater than 1, less or equal to 3. So you get this. Clear? Okay. As Apu got this graph and the inequality. Okay. So if you didn't get the answer, just note down anything. Don't just copy paste the board. If you're noting down the board, get the understanding and do it alone. Just don't copy paste the board. Okay, right. Number 3, using a black pen, the third type of special modulus functions. Write this. Functions consisting of functions consisting of two. What is the plural of modulus? Moduli. Okay, consisting of two moduli. Okay. So now look at this question number 1, 2, 3, 4, 5, 6. We got to draw the graph of y equals modulus x plus modulus x minus 1. Still, this haven't been asked for A levels. Still, like you haven't got this question to sketch the graph of this. But what I believe, if the theory of modulus is in the syllabus, they can give a question inside that range which belongs to the theory. So then after you get this, you can't say this is not in the syllabus. Because the question haven't repeated in 2000, after 2000, that doesn't mean that that is not in the syllabus. Because we do those mistakes. In trigonometry, even at some school tutors and other tutors, they don't do this part of trigonometry graph. So what is the reason that they are not doing this trigonometry graph? Is because the question hasn't been repeated after 2014. The last 2015, the last year that there was a question under trigonometry graph was 2050. So that doesn't mean that that is not in the syllabus. If something is taken out of the syllabus, they clearly give it. This is not in the syllabus anymore. This is not in the syllabus anymore. If not, we can't take the risk that assuming that it is not in the syllabus. Clear? So here, like we can draw this based on the knowledge of modulus. So this is how we do this. Clear? Listen, listen one line. Okay. No any sleepy faces. Huh? Still there are sleepy faces. Jannat lage tha. Okay. Now, if you take this separately, y equals modulus x. I know it's x and minus x. When x is greater or equal to 0, x is less than 0. So you can do this. I'll just take out this mod. You can take out this. Even though you take it out or not, no any change. Even you put it, you are getting the same. And if you take this separately, x minus 1, you get x minus 1 and minus x plus 1 based on x is greater to 1 and x is less than 1. Clear? Okay. Now this is what we do. I take a number line. And I'm marking the two turning points. So this is x equals 0 and this is x equals 1. And now what I'm going to do, after marking the two turning points, we have three ranges. We have one range that this is less than 0. The other range, it's greater than 0, less than 1. This range is, it's greater than 1. So we have three ranges. So here I'm considering modulus x. Here I'm considering modulus x. Here I'm considering modulus x minus 1. So we have three ranges. Now asking a question. I'm asking a question from each side. Now look at this. When x is greater than 0, modulus x is x. When x is less than 0, modulus x is minus x. Is it clear? Clear. Okay, now look at this. So now I'm asking the question, what is this range? The range is x is less than 0. No? He was in a movie, what? Reading an article. No? Okay. I'll be telling the school name next time because I see school batches. So I'll be telling the school names because I know almost every batch. I can say Royalists, Josephians, Peterites, Anandians, Thurstonites, Mahanamians are here, Paulians, Visakians, Anulians. Yeah, good. So I'll be telling the name, school name. It's called among. I'll give some credit for the school. Okay. Okay, listen. And I'll tell it in the proper way. Like if it is from Thurston, it's Thurston Nights. I know the proper name. I won't say Thurstonian, so you don't have to worry about that. I'll say it in the proper way. Okay. Taken sir. I call it. I'll give a pride, but you make sure you have to earn the pride. Okay. Okay. Hmm. Silence. No, listen. Look at the board. So here, this is modulus x. No. So my question is, I'm now referring to this range. Now you tell me in this range, x is less than 0. No. So when x is less than 0, what is modulus x? What is modulus x? Minus x. So in this range, modulus x is minus x. Is it clear? When x is greater than 0, what is modulus x? What is modulus x? X. So even this range, it's greater than 0. This range is anyways greater than 0. So when it is less than 0, modulus x is minus x. When it is greater than 0, modulus x is x. So even this one, it's greater than 0. So it's x. Is it clear? So what did I do? I have put modulus x in the ranges based on this. So when x is less than 0, it's minus x. When x is greater than 0, it's x. So this part is even greater than 0. Okay, now come to here. Now what is this part? I'll start from here. 1. When x is greater than 1, this range is x is greater than 1. When x is greater than 1, what can you say about modulus x minus 1? What can you say about modulus x minus 1? X minus 1 is x minus 1. So in this range, it becomes x minus 1. Okay, x minus 1. And now, what is this range? X is less than 1. So in this range, when it is less than 1, what is modulus x minus 1? What is modulus x minus 1? A minus x plus 1. So greater than 1 and less than 1, and even this part is less than 1. So even this is minus x plus 1. Is it clear? So first thing, we have to write the definition of the moduli in the ranges that we have taken based on the turning points. So we have two turning points. Mark the turning points on the number line, on a rough number line. And then you have to write the definition of the moduli in these ranges based on their basic definition. Okay, hands up if this part is clear. Okay, then let's do in this way. Write this. When a function consists of, when a function consists of, when a function consists of two moduli, two moduli, we have to mark the turning points. We have to mark the turning points. We have to mark the turning points on a number line, on a number line, and write the definition, and write the definition of each modulus, and write the definition of each modulus in each region, in each region. Okay, then do number 6, question number 6. So when you separately consider these two, you get this. Consider the two regions, three regions, less than 0, in between 0 and 1, greater than 1. So it's clear. So this is the turning point of modulus x. And this is the turning point of modulus x minus 1. So that's why when it is less than 0, you get minus x. And when it is greater than 0, both ranges, it's x. Here, when it is greater than 1, you get x minus 1. Less than 1, both regions, you get minus x plus 1. Minus x plus 1. Okay, so write this down. So try to get the idea and write it. Just don't copy paste. Okay. Okay, now silence. The main part. Listen. Listen. So here we have taken modulus x separately and modulus x minus 1. But what is required, not modulus x or even not modulus x minus 1. We need to consider the addition of these two. Okay, now I'm going to add these two, modulus x plus modulus x minus 1, in these given regions. I'm going to add these these two in the given ranges. Okay, now it's clear. When you add this, look at this. When you add in this region, when you add these two, minus x, you get minus 2x plus 1. You get minus 2x plus 1. Minus x plus x cancel off. Here you get 1. X plus x, you get 2x minus 1. That means in the three regions, you are supposed to draw the straight lines y equals minus 2x plus 1, y equals 1, and y equals 2x minus 1. Which means in the given three ranges, you are supposed to draw the straight lines. In here, it's y equals minus 2x plus 1. Here, it's y equals 1. And here, it's y equals 2x minus 1. Silence, silence. Okay, so now this is how you draw this. Take a Cartesian plane, and one turning point is 1. The other turning point is it's 0, 1. No? So take a. So one turning point is 0. Silence, silence, silence. One turning point is 0 and the other turning point is 1. Okay, now look at this. So when x is less than 0, you have to draw y equals minus 2x plus 1. That you can draw. You can do that. The intercept is plus 1. Intercept is plus 1. Okay. And I'm drawing a graph from here, which is having a minus 2 gradient. I'm sketching a graph starting from here, which is having a minus 2 gradient, but it is only valid when x is less than 0. Only valid when x is less than 0. Then, in between 0 and 1, you got y equals 1. Can you remember we discussed about y equals 1? What is y equals 1? It is a straight line that is parallel to the x-axis. So inside this region, inside 0 and 1, you get y equals 1. So this is y equals minus 2x plus 1. This is y equals 1. This is y equals 1. And the last one, when x is greater than 1, you have 2x minus 1. So always find the values in these bordering values. So here I took the value when x equals 0. Here, take the value when x equals 1. It's clear when x equals 1, you get 1. So that means it's starting from 1, 1, and the gradient is plus 2. The gradient is plus 2. And this is the graph. You get a basin shaped graph. Basamak wage. Wage tamai. 2x minus 1. So this is the graph of y equals 2x minus 1. So this shape 1 is the graph of y equals modulus x plus modulus, silence, 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 modulus x minus 1. So what did I do? I wrote the definition, and then inside these regions, you have to separately sketch y equals minus 2x plus 1, y equals 1, and y equals 2x minus 1. And then make sure that when you are drawing these values, find this border-in value, the turning point. Here, get x equals 0. When I was sketching this, find the value when x equals 1. Always, when you are sketching these two, get the value when x equals this and x equals this. Okay, hands up if this part is clear. Okay, then after this one, do this one and then do question number 8. So after completing this, do question number 8 alone. Silence, silence, silence. So we are not copy pasting the board. So here at these two, so you'll be ending up with 3 straight lines. You will be ending up with 3 straight lines. Silence, silence. So after this, do question number 8. Same thing. Get the 2 turning points on the number line. Then write the definitions on the in the regions you get. Okay, so what is question number 8? Silence. You got x minus 1 modulus and modulus x minus 2. So take the 2 turning points, 1 and 2. take the two turning points 1 and 2. And here we will be considering modulus x minus 1 and modulus x minus 2. So it's clear when x is greater than 1, when x is greater than 1, you will be getting x minus 1 and x minus 1. So in both regions, no silence, huh? I can't hear anyone talking. So in both regions, because we know when x is greater than 1, it's x minus 1. And when x is less than 1, it's the minus of it. You get minus x plus 1. So meanwhile, this one, it changes when x is greater than 2 and less than 2. When x is greater than 2 and less than 2. So when x is greater than 2, we get x minus 2. But when it is less than this, we get the minus of it, minus x plus 2. We get the minus of it, minus x plus 2. When it is less than this, we get minus x plus 2. But I told you what we want is not x minus 1 or x minus 2 moduli separately. We want the addition of these two. So if you consider modulus x minus 1 plus modulus x minus 2. So when you consider, what do you get? In the range that x is less than 1, here you get minus x is minus 2x. So it's minus 2x plus 3. You are supposed to sketch y equals minus 2x plus 3 in this range. Here what do you get? Minus x plus x cancel off. So it's yeah, y equals 1. And in this range, it's y equals 2x minus 3. So these are the three straight lines that you have to sketch. Okay, hands up who have written this definition correctly. Y equals minus 2x plus 3, y equals 1, and y equals 2x minus 3. Hands up. Good. Everyone is there? Everyone is. Okay, then what you have to do, the three ranges, sketch the straight lines. X and Y. So mark the turning points 1 and 2. So I told you, so when you are drawing this corner one, y equals minus 2x plus 3, always find the value when x equals 1. So when x equals 1, it's y equals 1. So it starts from here. So from here, you need to sketch a graph which is having a minus 2 gradient. Which is having a minus 2 gradient. Okay, this is y equals minus 2x plus 3. And then in between the range of 1 and 2, it's y equals 1. So y equals 1 means it's a straight line that is parallel to the x-axis. And then when it is greater than 2, it's y equals 2x minus 3. I told you to find the value at this board, like this turning point. When x equals 2, 2 into 2 is 4, 4 minus 3 is 1. So it starts from here and having a gradient of 2. So this is y equals 1 and this is y equals 2x minus 3. So this basin shape graph gives you the graph of y equals modulus x minus 1 plus modulus x minus 2. Clear? So you can get the graph in this way. Okay, hands up who got these answers. Okay, so you can get ready to go. If there's anything, you can note it down. Okay, okay, Asal. So next week we'll be starting the new silence lesson. Huh? Okay, next week we'll be starting the new lesson, and even that is the commencement of applied maths. So we are starting vectors. So vectors, like probably you have done vectors for physics, but applied vectors in applied maths and vectors. Hey, you on the mic? So vectors in physics and vectors in applied maths are two, I consider it's two different areas, but vectors in applied maths is way advanced than vectors in physics. So let's say you have, most probably you have done vectors in physics. So after doing vectors in physics, if you find vectors a bit hard, that is totally okay, because I don't teach assuming that you have done this in physics. We'll be start from the beginning, and then we will be completing the entire lesson, including past papers. So mark these two dates in the vacation period. You are getting vacation on November 7th. No? So I'll be taking two Tuesdays, like in all the 4 weeks, we are having classes as usual, Tuesday, 3 to 7. But I'll be taking two Tuesdays, the morning time slots, to do two free seminars, one to cover logarithms and the other one to cover coordinate geometry. So you are getting the first Tuesday is November 11th, so not 11th. The two Tuesdays will be November 8, silence, November 18th Tuesday, and then November 32nd means December 2nd. December 2nd. So mark those two Tuesdays, November 18th and December 2nd. We will be having two extra classes, two free seminars in the morning, 8 to 2, and the evening class will be there as usual in the Tuesdays, 3 to 7. Okay, so only two Tuesdays I'll be taking. And I have kept the trigonometry unit test papers out. If you didn't get it last week, just check whether your paper is there. And if even the paper is not there, just let me know. Okay, so we are done for today. You can go home safe.